ever-increasing performance of jet carrier-based aircraft came higher takeoff and landing speeds, greater fuel consumption per sortie, and less endurance. Increased capacity catapults and arresting gear cope with the higher launching and recovery speeds and handle the heavier weights. But such equipment does not solve the problems of deck handling and landing technique. Rather, it may aggravate the difficulties. These conflicting requirements present a dire alternative: fewer aircraft or a sacrifice in the carrier's operational readiness. Furthermore, the longer wire runout of the latest arresting gear shortens the effective landing area unless the deck space allocated to parking is invaded. This handicap, coupled with higher engaging speeds, dictates a precision in landing which cannot always be achieved. The need for a longer landing area and a ready deck are further complicated by the stringent deck handling requirements of intermittent ASW and AEW operations. In the search for the solution, the angled deck arrangement of all the systems studied was found to offer the greatest potential, and meeting them without reducing the number of aircraft that can be operated from a given ship. The landing deck, angled to the ship's normal center line, provides a longer unobstructed runway for launching as well as for landing. Deck layouts may differ among conversions, mainly as to elevators and a third and fourth catapult on the angled deck. Despite these differences, the basic angled deck change provides for the much greater flexibility needed in today's carrier operations. Why an angled deck? Faster launching and recovery with less deck handling. Operating details will naturally vary to fit different flight deck arrangements. The deck handling objective, however, is the same for all. Keep a ready deck for launching and for recovery. For example, you prepare to launch a small routine ASW or AEW patrol. Select the aircraft, preferably from a spot which will serve to expedite the parking of returning airplanes. Then respot them aft on the angled deck for a free deck launch. Small groups of jets can also be launched aft if the ship has angled deck catapults. After launching, the deck is again clear and ready for immediate landings. Whenever necessary to make another launch, these recovery operations can be interrupted, and by spotting interceptors aft in the safe parking area, they can be kept in a ready status for immediate launching from an angled deck catapult. To launch and recover a larger group, say a strike force numbering up to about 16 airplanes, we'll resort to simple animation to show the pattern of aircraft traffic on the flight deck. This carrier has the usual forward catapults and 2 more on the angled deck. For a launch of about 16 aircraft, respot the group aft on the angled deck. The launch is then made on the after catapults, and the moment the strike force is airborne, the angled deck is again ready for landings. The flight deck may be rearranged to uncover a forward catapult should the launching of a second strike group be required. If room permits, the displaced airplanes may be respotted aft inside the safe parking line. Thus, with little effort and a minor interruption to launching, the angled deck can be made ready for recovery. The key to speed in launching larger groups is an orderly movement of aircraft with a minimum of deck handling. Centering the flow of traffic around uncovering the angled deck catapults is one way of doing it. This is done by respotting the airplanes aft to uncover the forward catapults. Start launching, feeding the forward catapults as soon as practicable with airplanes spotted on the port side in order to uncover the angled deck catapults. Then launch from all catapults. As the pack thins out on the flight deck, move hangar deck aircraft topside to feed the catapults. In recovering larger groups, deck handling is minimized by giving priority to striking below returning airplanes regardless of their maintenance status. Use the starboard deck edge elevators abaft the island for airplanes which can be turned 180 degrees after clearing the landing area. Less maneuverable aircraft, go down the forward starboard elevator. Spot the overflow forward. When the hangar deck is full, spot recovered airplanes forward and aft in the safe parking area. Leave a clear deck space near the island to facilitate parking the last airplanes to land. The operation of respotting the deck to strike below airplanes that require maintenance can be done by first uncovering the after starboard deck edge elevators. These elevators can handle up-status aircraft from the hangar deck. Down-status airplanes can be struck below on the port deck edge elevator. Hence, the flow is down the port deck edge elevator, up the after starboard elevators, and then aft onto the angled deck. One of the more pressing problems in maintaining a ready deck is that of fouling by landing accidents. But the only barrier and barricade accidents occurring on an angled deck carrier are premeditated. Why? Because barrier and barricade engagements will be necessary only when the arresting hook is unavailable for arrestment, when the extension system is faulty or the hook breaks in the early stage of arrestment and necessitates becoming airborne again, and when only one pass can be made owing to damage to the airplane or to low fuel. Once the pilot is committed to a barrier or barricade engagement, he should concentrate on making it a good one. For instance, with this type landing gear, it is imperative that the nose wheel be eased to the deck so it will be on the deck at the engagement. Well-trained men with constant practice can rig this barricade or a barrier in less than 2 minutes, so either can be ready in time of need. The secret of fast rigging is proper stowage. Here's how it's done on early conversions. Later ships, however, have barrier and barricade ready stowage compartments directly below the flight deck near the stanchions. A deck tractor quickly hauls the equipment topside into rigging position whenever it is needed. At the order to rig barricade, men at the stowage box pay it out. Others run it across the deck. Pry up the planking from the recess for the lower loading straps. Meanwhile, other men attach the ends of the lizard wires and the purchase cables on the stanchions. Raise the stanchions. Tension the barricade. Secure the vertical strap bungees to the deck cleats. And the barricade is ready. To stop nose wheel propeller aircraft in emergencies, a Davis-type barrier is held ready on the edge of the deck. When needed, it also is rigged in less than 2 minutes by paying it out from a coil, connecting the arresting wires and adapter, securing the lifter straps to the deck cleats, tensioning the barrier, and finally raising the stanchions. Still another barrier is the prop type for propellered airplanes with tail wheel type landing gear. Only in a few details do the rigging operations differ. You connect the barrier cables to the lizard wires, Raise the stanchions part way, connect the arresting engine purchase cables, raise the stanchions all the way, and the prop-type barrier is ready for action. With a ready deck, the only delay in immediate landings occurs when the ship's course or speed must be altered to obtain a suitable wind over the deck. Tests show that the direction of the wind over the deck can be safely changed from dead ahead to 20 degrees on the port bow. As a result, the carrier can remain on the primary course under a wide range of surface wind velocities and directions. You are now going to land on an angled deck. The landing approach pattern is basically identical to that used for the straight deck. Some straightaway in the angled deck groove, with jets requiring a longer alignment. Try it again, this time in slow motion. Notice how the funneling effect of the guidelines helps you to get in and to keep in the groove. The same funneling effect is obtained at night by slit lights, white for the center line and amber for the converging off-center lines. You are now making a landing approach in a jet. Cut. You don't retard a jet throttle at the cut point, only when you're sure the airplane is stopped. The plane handler at fly 3 lets the jet roll back enough to disengage the hook. On signal, you apply the brakes and advance the throttle to avoid taxiing delay from slow jet engine acceleration. On the taxi signal, release the brakes and roll ahead until you have enough momentum to make a turnoff. How long does this take? It can be done in less than 18 seconds from the cut signal to clearing the angled deck. No longer faced at every landing by the mental hazard of a barrier, you can concentrate on making low sink speed landings. For on this deck, the only penalty for overshooting the wires is another pass. The tension on the LSO is also relieved by the clear runway. As a result, he may be inclined to give unintended late cuts. Unfortunately, late cuts may drive pilots into a faulty technique of diving to the deck to engage the wires. Why an angled deck? There are many reasons. It permits carrier operation of high-performance aircraft. It permits a ready deck for recovery and for launching. Fewer respots, which save deck handling time and effort. Better landing conditions allow pilots to concentrate on making good landings. Ships can steam on a wider range of courses and still carry out launching and recovery operations. These and many other advantages will be realized as the angled deck is more fully utilized. The angled deck is another long step ahead in the development of the full power of the Fast Carrier Task Force and the Navy potential.